Hello everyone. So this is problem C of Codeforces round 1051, and we are given a tree of n vertices numbered from 1 to n, and of course it will have n minus 1 edges, which is associated with two integers x and y. So okay, let's see what that two integers are and what's its importance. Consider a permutation p of integers 1 through n, where p of I represents the value assigned to vertex I. Okay. For an edge u, comma v such that u is less than v with associated values x and y, its contribution is defined as follows. So if p of u, so value associated assigned to vertex I, okay, value assigned to vertex I. So value assigned to vertex u is pu. So pu is greater than pv. So you will get x. So x will be the contribution, otherwise y will be the contribution. So value of permutation is the sum of contributions from all edges. Okay. Okay. Your task is to find any permutation p that maximizes its total value. Okay, so that's the question, and we will get some edges. So u, v, x, y, n minus 1 lies, which means n minus 1 edges of the tree. Okay. So I think the question is clear. If it's not clear, you can read it again. So let me discuss the solution. I'll share my whiteboard. Wait a bit. I think my board is visible. Yeah, it's visible now. So let's consider second test case. Okay, 1, 2. So this is 1 node 2. They are connected 1, 5, 2, 4, 2, 3. Okay, 1, 5, 2, 4, and then 2, 3. So what is x and y associated with this 1, 2? So 1, 3. So x is equal to 1 and y is equal to 3. 2 is equal to 1. In 1, 5, we have x is equal to 2 and y is equal to 1. 2, 4, we have 5, x is equal to 5 and y is equal to 7. And in the S2, 3, we have values associated with it is 1 and 100. Okay. So we have to find. Okay, so these either for every edge, either x is the contribution or y is the contribution. So for every edge, either we'll get plus x or plus y. Okay, or plus y. So the answer is very simple. You want to maximize the contribution. So if x is greater than y, then you will want x to have the contribution. Else, if x is less than y, then you will want y to contribute. Okay. So what was the case? You have u less than v. Okay, this is true. Now, if your pu is greater than pv, then the contribution will be x, else y. It means if pu is less than pv, then our contribution will be y. Okay, so just tell me one thing. 1 is less than 2, okay? And 1 x is equal to 1, y is equal to 3. So you want y, okay? You want y to contribute in this edge. So what you will want? If this P1 was greater than P2, then you will get X, and else you will get Y. Okay, if this is the case, you will get Y. If permutation of 1 is less than permutation of 2, so you will get Y. So in this case, you will want P1 less than P2. Okay, now let's see here. 1, 5. 1 is less than 5. Okay, and 2 is greater than X is greater than Y. So we want 1. So it means that P1 must be greater than P5. P1 must be greater than P5. Okay, this is the case here. Now we saw this 1 5 edge, 1 2 edge. Now we are checking this 2 4 edge. Okay, 2 is less than 4 and 5 is less than 7. So we want a Y here. Okay, but your U is less than V. So what do you want? You want your P2 less than P4. So P2 must be less than P4. And what about this? U is less than V and your Y is greater than. Here also P2 must be less than P3. Okay. So this is the case. Now, what do you think? Can you get the permutation if you know this fact? Have you read about topological sort? If you have not read that, then first read that topic and then you will be able to solve this thing. Okay. So what I will do, so I will use a clever approach here. Okay. Let's say you encounter an edge U, okay, and V, and you see X and Y here, okay. So if you want X, if you want X, because X is greater than Y, then you will want permutation of U to be greater than permutation of V. And if you want Y, which means that Y is greater, then you will want permutation of U less than permutation of V. Okay, this thing. Now let's assume like I will show you one thing. Let's say that this is a directed graph. Let's suppose that we are creating a directed graph UV, and if U is before V, which means that U is pointing towards V, then P of U will be greater than P of V. This is my clever approach that I'm applying. Okay, and if this is the edge, then I will say P of V is greater than P of U. Okay, I'm making these two edges. So tell me one thing. If X is greater than Y, then what you will do? You know how to create adjacency list, okay? So I will just push my push to adjacency of U dot pushback V. Okay, you got it? What I'm saying? If X is greater than Y, then adjacency of U dot pushback V. Because and if this is the case, if X is greater than Y, and if Y is greater than X, then I will do adjacency of V dot pushback U. This will be the case. Okay. Now here, let's see. In this case, 1 5. Okay, so it's so messy. 1 5 2 4 3, and I think here it was 100. Here it was I don't remember. I think here it was 1 5. Let me see. 1 2. So here it was 1 3. 1 5. It was 2 1. Okay, so this is X, this is Y, this is X, this is Y. So don't get confused here. 2457 and 23 is 100. Okay. So this was the case. Now here I want x because x is greater. Okay. So I will just do adjacency of u1 dot pushback 5 because I want this permutation to be greater. Okay. I want p1 greater than p5. Okay. So, okay, let's see from here only. See, I want p1 greater than p5. So what I will do? 1, 5. Okay. Now I want p1 less than p2. So 2 and 1. Okay. I will want 2 less than p of 2 less than p of 4. It means that this is 4 and this is your 2 because this will be greater. You want 2 less than 3 also. So yeah, this is the case. Now I know this. I know this. Now what I will want? Okay. So you are given this director graph in the pictorial form. So can you just tell me what can be the permutation? Of course, you know that these two are the largest. This is smaller than the two largest one. Then this is even smaller. Then this is the smallest. Okay. But which is largest among these? It doesn't matter. That's why the question is saying that print any permutation because it doesn't have any unique one. Okay. So how, okay, so I can, guarantee that everybody will be able to tell the answer if the question was in the form of this picture and you just have to write on the paper, but how will you code it? So what I will do, I will, calculate the in degree of every element. Okay. So in degree of this is 0, in degree of this is 0, in degree of this is 2, in degree of this is 1, and in degree of this is 1. Okay. After calculating in degrees, I will, make a queue. Okay. And put all those elements which have in degree is equal to 0. I will push all those elements Q. I will push all those elements which has in degree is 0. And why I'm saying that? Because if an element which has in degree 0, it means it's not, smaller than anybody. It's the greatest up till now. Okay. So I will push 4 to the queue. I will push 3 to the queue. And remember one more thing. When I'm pushing 4, so the edge to which this 4 is connected. Okay. Okay. Just wait a bit. Yeah. So the edge to which it is connected, I will decrease its in degree. Okay. And why I'm decreasing? Because now these are disconnected. And suppose that both are disconnected, so its in degree will be 0. Now this is the largest, that's why I will decrease the in degree. Okay. And 3 is also connected to 2, so its in degree will now become 0. Now 2 will come because its in degree is 0. Okay, so I will push only those elements whose in degree is 0. Now when I push 2, it is connected to 1, so I will decrease the in degree of 1. Okay. So next time when I come, I will see in degree of 1 is 0. Then I will push 1. And when I'm pushing 1, I will like iterate to the nodes to which this 1 is connected, and I will decrease all of those nodes in degrees by 1. Okay, so only 5 is connected. So 5 in degree will be decreased by 1 and it will become 0. So the next time the 5, we will just, push 5. So you saw, so this 4 must be largest, then this must be second largest, or you could even say 3 comma 4. It doesn't matter because both had degree in degree 0 initially, so it really doesn't matter. But uh, yeah, we chose this 4 first, so yeah, of course this should be max. So I will say that p of 4 is equal to 5. You got it. Then I will say p of 3 is equal to 4. This will be 4. this will be 3, this will be 2, this will be 1. Okay. Now I think it was understandable. And then you have to print all the permutation. Then you will print 5 first, then 1, then 2, then 3, then 4. So this will be your permutation. Okay. So let me show you the code. I think that it was very much intuitive. Sorry, not intuitive, but you could understand what I'm trying to say. So yeah, this is the adjacency list, and I have taken one based indexing because I don't want to decrease u and v. So I will, yeah, input edges and x and y, which are the contributions. If x is greater than y, which means that permutation of u must be greater than permutation of v. So you will push v to u. Okay, so this is the directed graph, and if x is less than y, then you will push u to v. Okay, now I will check how many. So initially, how many uh, edges, not edges, nodes are there which has in degree equal to 0. Okay, and then wait a bit. Yeah, so yeah, I had some phone call. Yeah, so I was talking about which line I was. So yeah, we will input this node and also x and y. And if x is greater than y, then it means that permutation of u must be greater than permutation of y. So y is before v. Sorry, u is before v. So adjacency of u dot pushback v, and else this thing. Okay. Now we are increasing the in degree. Okay. We are calculating the in degree of each node. We iterate from u is equal to 1 to n. Then if this is your node v, okay, and this is your node u, uh, that is this one. So whatever node which is connected to v, we will increase in degree of v. Okay, so we will get the in degree. Now we will check how many nodes have in degree as 0, and if it's 0, then we will push it to our queue. So our queue will have some nodes already stored initially. Now this is our topo vector. So while queue is not empty, your in you will get front, and then you will pop. And what is this front? Which has in degree as 0. Okay, so your queue will always contain that node only which has in degree as 0. Okay, now you will push this node to you because this is largest as of now, because you already know na what I told you. So according to the rule, we have to push our largest element to the topo. And how do we know that it's largest element? Because it has in degree 0. Now I will iterate to the nodes of u, okay, and decrease in degree of all the nodes. And if now it's 0, then we will push it to the queue, and then again we will iterate. Okay, so this will happen again and again, and you will have your this vector field. Now you will create this permutation vector. Your initial value will be n. For u topo, so we will iterate from the topo, and p of u is equal to value minus minus. Okay, and this is post decrement, which means first value will be assigned to p of u, and then it will be decremented. Okay, so this was what we were talking about. Then you will print your permutation. I think it was very simple. So yeah, this was all about the problem C solution. See you.